Inside a nuclear reactor, concrete shielding, a steel vessel, moderator, fuel rods, and control rods. Neutrons travel sideways from one fuel rod to the next. Control rods absorb neutrons to keep the chain reaction controlled. Cold coolant enters at the bottom of the vessel. It rises through the hot core and picks up thermal energy from fission in the fuel rods. Hot coolant leaves at the top, carrying heat safely away from the reactor. That heat boils water into steam, spins a turbine, and generates electricity. Nuclear fission of uranium-235. A slow neutron is absorbed. The nucleus becomes unstable and splits. Fragments, more neutrons, and energy are released. The equation reads, 1 neutron plus uranium-235 gives barium-141, krypton-92, 3 neutrons, and energy. Question 8. Nuclear reactor. 3 parts: reactor components, nuclear fission, and specific heat capacity of the coolant. 8a. State the purpose of each part of the reactor. Concrete shielding protects workers by absorbing harmful radiation. The steel pressure vessel holds the core and withstands high pressure. The moderator slows fast neutrons so they are more likely to cause fission. Fuel rods contain uranium-235, where fission releases thermal energy. Control rods absorb neutrons to control the chain reaction. Inside the reactor, the vessel seals the core, and control rods slide between the fuel rods to absorb neutrons. (8b) Describe nuclear fission in the fuel rods. A neutron collides with uranium-235 and is absorbed. The unstable nucleus splits, releasing daughter nuclei, more neutrons, and energy. Those neutrons can trigger further fissions, a chain reaction. Control rods absorb enough neutrons to keep the reaction steady and controlled. A slow neutron is absorbed, the nucleus splits, and each fission releases more neutrons that strike nearby nuclei. (8c) Specific heat capacity is important in coolant design. From Q equals mc delta T for a fixed heat transfer, a large specific heat capacity to avoid overheating. With the same heat input and mass, a coolant with small c overheats quickly, while a coolant with large c stays cooler.